All right. Okay. So now what we are looking at here is to advance. We're looking to advance from equalities to inequalities now. So what does it mean? In mathematics, normally we're trying to solve a problem. Okay, it could be maybe the distance that someone has traveled in a specific amount of time. Then you are trying to calculate the speed. So then you have to create a statement, okay, or an expression. Once you create the expression, you can create an equation, okay, or depending on the conditions, you could be defining an inequality, because this one will give you a range of values. So normally you represent that with this sign, that sign, this sign, or that sign. Now, for example, here, you can have 2x plus 5 is greater than or equal to 7. So that will give you a range of values. So like you can see the difference here. 3x plus 2 is equal to 8. So remember we learned how to solve this. So here we said that depending on where you are, you could actually maybe just move that across, or you could show why this is like this. So we say 3x is equal to 6, then x is equal to 2, okay, like that. So once we say x is equal to 2, it's specific. This is a specific point on the number line. So the answer here will be something like this, specific point. But if you solve this same equation and it had inequality with this sign here, it means that maybe here you're going to have that point, which is 2. And then our answer now is going to be x is greater than 2. Okay, so it's giving you a range. And it says it's greater than 2, meaning that this is going to be, you're not including this point. Then your answer is going to be like that. Up to what? Up to infinity. So that is our inequalities. Okay, so the important rules when you are dealing with inequalities, it's to remember that there are things that apply, okay? So what applies when you have an equality like this, okay? And then you add equal values on both sides of the equation of the inequality. This sign remains the same. Okay, now if we go back to this same inequality, and then we remove the same value, the same number from both ends of the inequality, this sign remains the same. Doesn't matter if it's greater, if it's less, if it's greater, less or equal to, greater or equal to, this remains the same. Okay, now if we multiplied with the same value on both sides, okay, we multiply here, let's say with a 2, and there with a 2, and it's positive, the sign remains the same. But there are two special instances when the sign actually changes. It's when we multiply with the same value that is less than 0. Okay, so meaning that if I multiplied with -1 here, and I multiplied with -1 there, then this sign here changes to that sign. Okay, there's another, so here this applies to multiplication and division. Okay, so if I say A over C and B over C, a negative number, that also changes. Now we've got to remember what we learned in when we looked at negatives and positives and what they do to equations. So here, why does it change? So if I had -2 is equal to minus, let's say -2 is, let's say it's greater than -5, right? Now, if I multiplied this side with -1 and I multiplied this side with -1, let's look at what will change here in terms of the numbers. Here it's minus and minus, so we get 2. Here it's minus and minus, or negative and negative, then we get 5 here. So now, what is the true statement that we can have here? It's to say that 5 is greater than 2 or 2 is less than 5. So this is the reason why this sign changes. And it would be true if I had minus 2 over minus 1, or negative 1 or negative 2 over, divided by negative 1. We can say that this will be a positive, and the same here will be a positive. So meaning that this statement here will be true. The other instance when this changes is when this is, when we reciprocate these ones. Why does it change? We also need to understand, I'll just do it here. We need to understand. So for example, I've got 2 is greater than 1, right? If I were to reciprocate this, it will become 1 over 2. And then this side, I'll maintain 1. But then now 0.5 is what? It's less than 1. So you see, if you look at them from these values perspective, that change is inevitable. So when does it change? When you multiply or divide by a negative number, or when you do reciprocals of the numbers. So if 1 over a, if a becomes 1 over a, or b becomes 1 over b, the value changes. That is because initially this was less and that was bigger. So if I divide anything by what is bigger, it becomes smaller compared to when I divide with something that is less. Okay, so that is what is happening there. You just need to understand that. Now let's look at some examples or exercises. Okay, so these you must also practice. Maybe pause the video, try to solve on your own, and then see what answers you can get. So we've got this first one, and then the second one, and the third one, all different examples. Now, this one is a special case, okay, because there's something that we have to do in order that we can confirm the range here. These ranges are direct, but this range, you have to actually do something else to get the actual range. So let's start with the first question. The first question we said is 3x is less than 9x plus 4. And now remember we said that we are going to always put the like terms together, okay? So our like terms are going to be, this one will have to go this side. Now, we say that we have 2 ways in which we can do this, okay? It's the same way, but it's just that visually they look different. So you can say this one is positive, and so if it, well, lack of a better term, if it jumps to the other side, it becomes 3, it becomes minus or negative. So it becomes 9x. Then we maintain, there's nothing, remember we said there's nothing changes till you have those 3 special conditions. You flip, where you make the whole statement this side and that side, you make them into reciprocals. That changes the sign, okay? Or you multiply this whole side with a negative and the whole of this side with a negative. That changes the whole equation, right? So now we also are going to say that we're going to maintain this sign here, okay? We're going to maintain that sign because nothing special has happened. We looked at our special cases. All right, so we maintain our 4 this side. Now, these can subtract each other. So we have 6, but this time negative, 6x is less than 4. Right. We can also do 2 things here. We just, to remove this number here, because we're solving for x, we can divide with negative 6, and then we divide with negative 6 here. Now we say that if we divide with a negative number on both sides, what happens? this has got to change. Okay, so x is greater than this. We can now say is less than negative, is greater than negative 2/3. That is because I've reduced 4/6 to, I divide by 2 here, I divide by 2 here, then this becomes 2/3. But remember, we have a negative, so it becomes minus 2/3. That's the solution for the first one. Right? So remember, this has flipped because of what? Our special condition. We said that if we divide or multiply by a value or a number that is less than 0, that changes. So this is less than 0 and we've divided. So this has got to change. Right? So that's our first example. Now let's go to the second example. The second example is 4 is less than or equal to 3x minus 2 minus 13. So when you see this that has got two inequality signs, it just means that they've combined two inequalities into one so that it gives you a set of solutions. Okay, it gives you a specific set of solutions. So you can solve this independently and that independently, then you put your solutions together. That is possible, but the easiest way is to continue to separate all aspects from the middle to just leave x, and then you make sure that on the sides you are doing the same thing. When you do one thing here, you do it the other side as well to maintain the balance. Okay, that's the rule. So what do? We're going to move this to this side, but the same value also has to move the other side, right? So whenever these things keep to the other side, we say that we change the sign. We're trying to make it easier. We already know why this is changing like this. It's because we're trying to get rid of this. So we're going to add a +2 here. We're going to add a +2 there, a +2 there. That's why we get a positive. But the easiest way, the quicker way, is just to say when this goes over to the left-hand side and it was on the right-hand side, it gains the opposite sign, right? So here we have 3x, we remove our 2, then this becomes like that. Remember, the sign remains what it was, right? So here we have 13 plus 2, right? We've maintained this. This becomes 6, step by step, right? This is what we're trying to do here. And then here we have 15. Okay. Now we continue. What is the next thing that we can do? We're going to do the same thing everywhere. All right. So we do this and then divide by 3 there. So we have 2 is positive, nothing changes. Okay. Here we have x, and there we have what? We have 5. So this is our solution set. 2. So x is such that x is greater or equal to 2, but less than 5. Right. So that's our solution there. Now we go to our final example. Our final example is what? Our final example is x squared minus 5x plus 6 is less or equal to 0. Now this is a bit tricky, so you have to pay attention here. Why is it tricky? It's that it gives you 2 solutions. So now if it gives you 2 solutions, you have possibilities to have 3 different ranges. But how do you pick the correct ranges? So this is where the trick is. Now we'll see how we do that. So first of all, we solve it as normal. So how do we solve this as normal? We looked at factorization where we said we get the product, we get the sum, and then we get the factors. So the product here is going to be 1 times 6, which is 6. The sum is going to be minus 5, meaning that, remember I said minus minus times minus, we get, in fact, we get the factors first. Okay, so we get the factors. What are the factors? And then here we get the sum. Let me delete this. Okay, so we get the factors. We get the factors that can give us this sum. What is our sum? Our sum is minus 5. So we look at the factors. The factors obviously is 2 and 3, but they have to be negatives in order for us to get minus 5. So this changes to x squared minus 3x minus 2x plus 6 less or equal to 0. So now we have x. We can skip to the factors, but it's always good just to practice this each time. Okay, so we have x minus 2 like that. Then we have x minus 3 like that, right? Meaning that now we cannot just go and say x, therefore, because we're not dividing or multiplying with a negative, we can say x is less or equal to 2 and x is less or equal to 3. We cannot do that, because if this was the solution, then it means that this is not necessary, because this it is a factor of this one. So we cannot have that situation, right? So what we're going to have is that we the easiest way is to put up a number line like that. Now we know that the solution is a product of factors. Okay, so we need this. It says it's 0 or less than 0. Have you seen? So what we do is we get these two factors, the solutions here. We know that the solutions here are our solutions here. I think we're experts now. So our solutions here, it's 2 and 3, right? It's 2 and 3. So we can say that our solutions, if it was equal sign here, our solutions are going to be 2 and 3, positives. So I go to my number line, I put 2, right? And I'm looking at this, it includes this. So I'll put solid dots. And then I've got a 3 here, right? Now, what happens is that I'm looking for something that will give me this, less than 0, meaning that I'm looking for something that will give me negatives. So what do? I look at something here. I look at something here. I look at something here. See what values I'll get. Okay, so now what do I get? I look at here. I can get a 0. 4. So this has to be applied to this factor, and I have to apply it to that factor as well. Okay, so I get 0 because it's less than this. I check this range here to see if it's possible. So I get 0 here, right? So if I put 0, we'll be trying on this side. So if I get 0 minus 2, it'll give me negative 2. So I've put my factors here. So x minus 2 and then x minus 1. Then I get their product here. So this will give me a negative. I just check the signs. So this is negative. If I put a 0 here, 0 minus 3, it will give me negative 3. So I put a minus here. Then the product of these two is positive. So now you can see if it's positive, it means that it's greater than 0. So that is not what we are looking for. We come here, we look at half. Okay, we can look at 2.5, which is 2.5. So 2.5 minus 2 gives me 0.5, which is positive. Then 2.5 minus 3 gives me 0.5, but minus. So for this one, I'll get a positive. And for that one, I'll get a minus. The product of these two, it gives me a minus. Which is what? So I'm checking these ranges. Remember, we're just checking these ranges here. These three ranges here. And we know that this is going to be x is less or equal to what? 2. This one is going to be 2 is less or equal to x, and x is less or equal to 3. Right, let's continue. We check this side. Now I'll get a 4. Okay, anything above 3. So I'll get a 4 to make it easy for myself. So I'll say 4 minus 2. 4 minus 2 gives me a positive, which is 2. So I'll put a 2 here, a positive. Then 4 minus 3 gives me 1, which is a positive. It gives me a positive. So my answer is positive here. So now if I look at positive here, this is not correct. The only one that's correct is this one. Okay. So this is correct here. Meaning that our solution set, therefore, is going to be this answer here. So meaning that our final answer is going to be 2 is less or equal to x, and x is less or equal to 3.